Right, so in this video I'm going to combine percentage yield and atom economy. Both of these topics would have come up in SC14, so we would have done them towards the end of year 10. They're both really straightforward and simple marks should they come up. So percentage yield, if we just look here at a reaction, you've got sucrose and water and it makes ethanol and carbon dioxide. And when we do our moles table, just say we were told how much sucrose we started with. We start with 10 grams of sucrose and they wanted to know how much carbon dioxide are you going to make. And you fill in your moles table and you work out that you should make 2 grams of carbon dioxide. This number that we've worked out is called the theoretical yield. It's the amount of carbon dioxide that we should make in theory if the reaction went 100% to completion and nothing went wrong. In actual fact, when you do a chemical reaction, you're not going to get the full 2 grams of carbon dioxide. And there are a number of reasons for that, which you'll find in your booklet. Sometimes a reaction may just be incomplete, so you just didn't leave it long enough. Sometimes you might get this competing side reaction that you weren't anticipating, so two things can react in a way that you weren't expecting. And one of the most common is when you're doing a reaction, you often have to move your reaction mixture from one flask to another if you're trying to purify your product, for example. So if you think back to year 10, we would have made a salt by reacting an acid and a base, but once we made that salt, we had to filter it, then we had to evaporate the water. So you're going through a series of purifying steps, and in each of those steps, you're likely to lose some of your product. So this is what we should make, but in reality, we'll make less. And percentage yield is just taking what you actually get and dividing it by what you should get in theory and just timesing it by 100. So there's a few examples of that down here. So here, they give you the formula for its actual divided by theoretical. This you can all get from the mark scheme, but it says here, use the information to calculate the percentage yield. All right, so the actual yield, how much did you actually get, is here, 8.07. That's the mass of ethanol obtained from the reaction. And then underneath, in theory, the amount of ethanol you should have got. All right, so you'll see your actual is a lot less. So it's going to be 8.07, your actual, divided by 53.80. Times that by 100, and that's it. Okay, that's your answer. That will get you your 2 marks. Again, the rest of this you can get from the mark scheme. The next question, they tell you in theory, in this reaction, you should make 5.600 grams. All right, so that's your theoretical yield. And they tell you here, the mass that you actually get is 5.450. So again, it's actual 5.450 over theoretical times by 100 equals. Okay, when you're doing these, your answer should always be less than 100%. If you get an answer greater than 100%, then you have these two numbers the wrong way around. Your actual, the amount you get, will always be less than what you thought you were going to get in theory. Next up is atom economy. So atom economy looks at how many atoms from your reactants ends up in the product you're trying to make. So here, the whole point of this chemical reaction is to get lead. So you react lead oxide with carbon and you're trying to get lead. But during this reaction, you make an unwanted product, all right? You make CO2, and CO2 is essentially a waste. You're not trying to make it, it's just a waste. And when you're looking at atom economy, you're looking at how many atoms out of the ones that you started with end up in the product that you were trying to make, compared to how many of these atoms end up in the waste product. And are, essentially just a complete waste. And in order to work this out, you are going to take the formula mass of the product that you want. Okay, so we're looking at product of the product that you want, and you're going to divide that by the formula mass of all products. All right, so if I'm looking here at the product side, I've got lead and I've got carbon dioxide. Okay, you're going to have to read the question to find out which product you actually want. So it says here lead can be obtained, so that's what you're trying to do. Okay, it's the production of lead, so lead is the one that you want. Okay, so I need to get the formula mass of lead. Now in these atom economy calculations, you are going to use the big numbers from the balanced equation when you're getting formula mass. Okay, because you're making 2 equivalents of lead and that needs to be taken into account. So I'm going to have 2 times lead here is 207. So that's the formula mass of the product I want, divided by the formula mass of all products, which again is going to be 2 times 207 because I've got 2 leads, plus I've got carbon dioxide is 44, and then I work that out as a percentage and I get atom economy. The next one, something similar, okay? So they're saying calculate to produce ethanol. So they've given you this reaction, we've seen it already actually, and they're telling you that you want to produce ethanol, but during this reaction, again, you also make carbon dioxide. Okay, so the product I want is ethanol. They tell me the formula mass of ethanol down here is 46. Because there's a big number 4, it's going to be 4 times 46. That's the formula mass of the product I want. And I'm putting that over all of the products. So it's going to be 4 times 46 again, plus 4 times 44 for the 4 CO2s that I am making. Okay, so formula mass of the product you want over the formula mass of all products. And again, you're working that out as a percentage. You get 3 marks for that. So it's really not difficult. And then it says that, oh, this is a great question. It says down here, explain the effect on the atom economy of this reaction if carbon dioxide produced was used to make fizzy drinks. Okay, so the whole point of atom economy, of calculating these values, is you don't want anything to go to waste. But by taking carbon dioxide, which is not what you're trying to make, and finding a use for it, nothing goes to waste. And if nothing goes to waste, your atom economy is suddenly going to be 100%. Every single atom that you start off with in your reactants goes towards a useful product. Ethanol is what you're actually trying to make, but by finding a use for the waste product, nothing gets wasted and your atom economy goes to 100%. Okay, so explain the effects if the carbon dioxide produced was used to make fizzy drinks. You can say there are now no waste products, therefore atom economy is 100%. No atoms are wasted in this reaction.